Okay, we have seen that for firms, in order to maximize profit, if they follow MR equal to MC to determine how many quantities they want to produce, then go from quantity up to demand curve to read out the price, and then compare the price with the average cost or average variable cost to see if they should operate, stay in business, shut down, or exit the market. We look at two markets so far. One is a perfectly competitive market. So in this market, firms take a price as givens. And in the long run, because of free entry and exits, there's no possibility to have a positive economic profit. So the best firm the strategy that the firms can use here is trying to be as cost efficient as possible. And they may also pay for a firm to move into the market before others. The second type of market we look at is a monopoly market. So here, a firm is the sole suppliers. However, these firms cannot be complacent or arrogant and assume their ability to earn economic profit can never be diminished. They are still faced with a downward sloping demand function. In addition, changes in economics of business eventually break down a dominating company's monopolistic powers. Right, so we see that we only look at linear demand. We only look at linear demand like this straight line, and we say that the margin revenue curve is twice steeper than demand function, and here is the margin cost. Follow a micro MC, get a quantity, and go from quantity up to the demand curve, read out the price, and compare this with the average cost or average variable cost to work out the profit. Okay. Let's do a little bit algebra. So here the pricing can be sought intuitively can be sought as firms just set a markup on top of the marginal cost of production, where the markup really depends on the price elasticity of demand. So how sensitive consumers respond to price change. So if this price elasticity of demand is high, consumers are very sensitive, firms cannot put a high markup. In contrast, if it is low, then firms can put a high markup on top of the marginal cost of production. So let's do some sort of derivations here. So we know that total revenue is price times quantity. So in order to get a margin revenue, we differentiate total revenue with respect to quantity, so which is equal to, so here we have Q here, and we also implicitly P is a function of Q by inverse demand function. So it's differentiate. Let's differentiate with this Q first. So it's 1 times dQ over Q plus Q times dP over dQ, and this is 1. Okay. So let's pull P out. Bring it 1 plus dQ over dP, sorry, dP over dQ times Q over P. Okay, so now we know that the price elasticity demand is dQ over Q, percentage change of quantity over percentage change of price. And we should know that actually we need to have a negative sign in the front, because we know that dq over dp is negative by lower demand. Rewrite this equation, we can write it as dq over dp times p over q. So these terms is just equal to 1 negative 1 over the price, that is the demand. So we compare this term to this term, they're just opposite, inverse of each other. So we have minus 1 over epsilon. That's the MR. Equate MR equal to MC. Okay. We can write okay, I'm going to just use this one. So we can write P minus MC is equals P times 1 over epsilon P, or the markup that's the price they charge, that's the marginal cost. The percentage markup is 1 over the price elasticity of demand. Okay, that's marginal. That's MR equal to MC, marginal pricing. There are also other non-marginal pricing as well, as our textbook talks about the cost plus pricing. In these cases, if MC, marginal cost, is close to average cost, and MR equal to MC will be same as MR equal to AC. Okay, that's cost plus pricing. Okay, so we know that MR equal to MC, and firm decide to produce Q unit, charge a price of P. For the first unit, okay, go from 1 up to the demand curve, read out say $10. Read out the price. So for this unit, consumers are willing to pay $10, and they pay dollar of say $6, pay price of $6. For this unit, we see that the consumer enjoyed $4 surplus, and that's the first unit. Second unit, similarly, there's a consumer surplus associated with second unit, so on and so forth until the Q unit. So this area is consumer surplus. All right, let's see. Can we extract? We are standing at the firm's point of views. Okay, and the firm's objective is to maximize the profit. So here naturally comes the question: can we extract this consumer surplus using some sort of other pricing strategy? The answer is yes, and it somewhat depends on the information firms have, and we call this price discriminations. So products with identical costs, firms sold them in different markets at different price, or charge different consumers at different price. So in such cases, the ratio of price to the marginal cost will differ for similar product, or for different consumers. And we need a number of conditions to be satisfied in order to implement price discriminations. For example, the markets in which the product is sold must be separated. We should be able to separate one market A from market B, such that there is no resale between the markets. and demand curve must be different across the markets. All right, there are three types of price discriminations. First one is we call the first degree price discriminations. So here, seller can identify where each consumer lies on the demand curve, demand function, and charge its consumer the highest price they are willing to pay for each goods. Okay, for example, suppose I'm the coffee shop. I know the demand curve. I know, say, Mike is like coffee very much, and he's willing to pay $10. And Jane does not like coffee that much. He's only willing to pay $6. And if I observe all these people, all my consumers are willingness to pay for my coffee, I can charge a coffee at the maximum willingness to pay. For example, I can sell my coffee to Mac at $10, and Mac will buy it, and sell my coffee to Jen at $6. Jen will buy it because that's what she's willing to pay for it. Okay, so that's what we call it first degree of price discrimination, and in doing so, firms can make the greatest amount of profit. We can see that in doing so, the firms actually extract. Suppose this is marginal cost. Okay, it says coffee, it cost me $3 and 10 cups of coffee. And doing so, all these consumer surplus transfers to the firms. Firms extract all consumer surplus. However, to do so, it requires me, the firms, the coffee shop, observe every people's willingness to pay. And this is frequently not available actually. And also I need to somehow prevent prevent reselling among my consumers. For example, I know Mike is willing to pay $10 for my coffee. Jane is willing to pay $6. So I'm going to sell the coffee to Jane at $6. Okay. So what the consumer can upset my strategy is Jane purchase the coffee at $6 and resell this coffee to Mike, say at $8. Okay, then Mike will be very happy. Mike get $2 surplus, and Jane get $2 profit. Okay, so in such way, Jane actually successfully upset my first degree price discriminations. Alright, so if such information are not available, we can also implement what is called second degree price discriminations. So here, rather than charge different consumers different price, so differential prices charged by blocks of service, blocks of goods, okay? And it requires metering of services consumed by buyers. We can also practice what is called third degree price discrimination, and this is actually quite frequently observed in reality. So here consumers are segregated into different markets and charge different prices in each market. So somehow we have more than one market, and at different market, because at different markets demand are different, we are going to follow a micro MC in each market, and we end up in charging different price in different markets. So such kind of segmentation can be based on any characteristic such as age, geographic locations, gender, income, etc. Okay, so let's look at this block pricing or second degree price discriminations. So this is my MC curve is constant, so equal to average cost. And I'm faced with downward demand function. and my MI is twice steeper than the demand. So if I follow MI equal MC, I'm going to produce at this point. That means 6 unit output go from quantity up to the demand curve, read out the price 10. So profit is 30. Okay, 6 times 5, so it's 30. All right, let's try to do better than this. So now the same demand, the same marginal cost. I'm going to say, okay, I'm going to produce at this point, which is 12 units instead of 10 units as we see previously. Okay, I'm going to say 12 units, but I won't sell these 12 units unit by unit. I'm going to say it's a block. Okay, I'm going to sell this 12 unit in a block. Charge a price of the whole area. So that's 5 times 12. So that's this area plus this triangle. So which is 1/2 times the length of this size, 10 times 12. So it's 100. So it's 120. Okay, so the price is 120. Take away the cost of 60, so I can earn $60 profit. And previously, if I follow MI equal to MC, I only get 30. So this is second degree of price discrimination. For the third degree of price discrimination, the aim here is try to mimic first degree price discrimination, charge high prices for those who are willing to pay high, and low price for others. So here I need to find a way to segment the market. So I can identify different groups of consumers, and these could be, say, geographical locations, say Australian market and New Zealand market. And I need to be able to prevent those in different markets of reselling. Say some people consumers might buy in the low price market, resales in the high price market, and that disrupt my strategy here. All right, let's look at a diagram. So here we have three graphs. So here is market A, two markets. Market B, A has demand, downward sloping demand, and is steep, so it's inelastic. And B is flat, so it's elastic. So if we cannot charge different prices in different markets, that means we have to aggregate. The aggregate demand will be, say, we're going to add the demand from the two markets horizontally. When prices are higher than this level, then there's only demand. Demand only comes from market A, and there's zero demand from market B. So we shift this segment into here. Okay, that's when price is higher than that level. If price is lower than this level, then suppose price is at this level, okay, then demand from market A is this many, so move this to here. Demand from market B is this many, move to here. Add them up, we get this total demand here. Okay, and this way we sum up the demand from the two markets, we get a total demand of this. So if I'm not able to segment the markets, then the best I can do is I'm only following MI equal to MC. So this is my MC, and MR from this this kink demand, I'm able to derive the associated marginal revenue for M equal MC. Okay, so that means produce this many unit output, go from quantity up the price, charge the price this many. However, if I'm able to charge different price in different market, we're going to do it this way. So we are going to in each market here, we get the same market A. We have demand here. We have associated MR equal MC, produce this many units and charge a price of PA. Similarly for market B, which is PB, and we can see that a price in market A is higher than price in market B. And this is because of consumers in market A are less sensitive to price change, or is more inelastic. The demand curve is steeper than B. So the firm finds total amount produced by equating the marginal revenue and the marginal cost in the market as whole. Okay, so again, total revenue, total quantity output here, M equal MC at this point. Okay, so which means QT, this many units output. But rather than go from the QT up to the demand curve without the aggregate demand curve without the price, so what we are going to do is go from this point to horizontally to both A and B. So get this point, and get the associated quantity. So for market A is this many, for market B is this many. Then go from quantity up demand curve up to the demand curve in the market A without the price, and go from quantity up to the demand curve in market B without the price. Okay. So in order to find the optimal price to charge in each market, draw a horizontal line back here. So we see that price in market A is higher than price in market B because market A, the demand is less elastic, while market B is elastic. Okay, this is third degree price discriminations.